Hi students, welcome to my channel Excellent Ideas in Education. Today we are going to draw shear force and bending moment diagram for overhanging beam with UDL as shown in figure. You see this drawing, three forces is given, one UDL load is given, B and C is the overhanging beam. In this, first we will draw free body diagram of the given support. Second, using equilibrium condition to find RB and RC. This RB and RC value we need to find. Third one, we will calculate shear force. Fourth one, we will calculate bending moment. Fifth one, we will draw shear force drawing based on the shear force calculation. Sixth one, we will draw bending moment drawing based on the bending moment calculation. Now we will draw free body diagram. You see this drawing, UDL is given, we need to convert into point load. You see here is B, here is A. So we will take this is as a 1 UDL, this is as a another UDL. After that, this is as a another UDL. This is D, C, B. UDL into distance. This is also UDL into distance. UDL into distance. You see here UDL is 12. So 12 into, you see this distance is 2.5. 2.5. 12 into 2.5 is 30 kilonewton. You see this UDL is 12. Distance is 4.5. 12 into 4.5. This is 54 kilonewton. Next, you see this one. This is 3 distances. UDL is 12. 12 into 3 is equal to 36 kilonewton. The 30 kilonewton, how you will place the point load, how to find the distance in this case? This is B by 2. What is B? B is given as 2.5 divided by 2 equal to 1.25. So this distance is 1.25. This distance also 1.25. Load is 30 kilonewton. This is A, this is RB. This one 4.5. So how you will place the point load? How you will calculate the distance? This is also B by 2. What is B value? B value is 4.5 divided by 2. It comes 2.25. So this distance is 2.25. This distance also 2.25. So point load is here. This is 54 kilonewton. Here is RC. How you will find the distance in this case? This is given as 3. So B by 2. So 3 by 2 is equal to 1.5. So this load is 36 kilonewton. Distance is 1.5. Here is also 1.5. This is D. Now we finished FBD. Next we will find RB and RC. To find RB and RC. First we will calculate summation of f of x is equal to 0. First we will draw the graph. This is x-axis. Here is y-axis. So x-axis is in horizontal, y-axis is in vertical. You see here in this FBD drawing, any horizontal force is there. Summation of f of x, horizontal force is not there. So no need to calculate this one. This one you need to neglect. Next, we will find summation of f of y is equal to 0. You see y is in vertical. The vertical upside is positive. Here is 30 kilonewton. You see this arrow comes down. You see the arrow goes up is positive, down is negative. So we will write minus 30. Next, you see the arrow comes down. Down is negative, minus 30. Next, you see the arrow goes up. Up is positive, plus RB. Next, you see the arrow comes down is negative 54. Next, you see the arrow goes up. Up is positive, plus RC. Next, arrow comes down. Down is negative, minus 36 equal to 0. RB plus RC is equal to 150 kilonewton. Next, we will calculate summation of moment B is equal to 0. Clockwise is positive. What is the moment formula? Moment is force into perpendicular distance. You see the B force, if you have applied moment in the point B, that force should be 0. Why? The distance of the point is 0. You see no distance is there. So RB into 0 is 0. The distance of the point is 0. The moment also 0. You see this force acts downwards from here to here. This is anti-clockwise. Anti-clockwise is negative. Clockwise only positive. So negative 30 into what is perpendicular distance from here to here? You see 2.5. 2.5. Next, you see the arrow comes down from here to here. You see anti-clockwise. Anti-clockwise is minus 30 into perpendicular distance from here to here is 1.25. 1.25. Next, you see this arrow comes this side. So this side is clockwise. Clockwise is positive. Plus 54 into perpendicular distance is from here to here. 2.25. Next, you see this arrow goes up from here to here. This is anti-clockwise. Anti-clockwise is negative. Perpendicular distance is 4.5 minus RC into 4.5. Next, you see this arrow comes down from here to here is clockwise. Clockwise is positive. 36 into distance is from here to here 4.5 plus 1.5. So 6 plus 36 into 6. Minus 30 into 2.5 is minus 75. Minus 30 into 1.25 is 37.5. Plus 54 into 2.25 is 121.5 minus 4.5 RC plus 36 into 6 is 216 equal to 0. Minus 4.5 RC is equal to minus 225. Minus minus cancel. RC is equal to 50 kilonewton. What is RB value? RB is equal to 100 kilonewton. So RB, this is 100 kilonewton. RC is 50 kilonewton. FBD finished, RB and RC finished. Next, we will calculate shear force. Next, we will calculate shear force calculation. First, we will see two rules of shear force. This is positive shear force. The arrow goes up is positive. Arrow comes down is positive. This is left side. This is right side. This is positive shear force. First rule. Next, we will see negative shear force. Arrow comes down is negative. Arrow goes up is negative. This is left side. This is right side. This is negative shear force. This is second rule. First, we will find shear force at A. You see the shear force at A. The load acts in the downward direction. You see the arrow comes down. Left side is negative, minus 30 kilonewton. This is left side. Or right side. Left side and right side answer should be same only. What is shear force? Algebraic sum of the vertical forces acting on the left or right of the cut section along the span of the beam. You can calculate left or right side of the shear force. Both answers should be same. Now we will calculate right side. You see the arrow comes down. Down right side is positive, plus 30. Next, you see the arrow goes up. Up right side is negative, minus 100. Next, you see the arrow comes down. Down is positive, 54, plus 54. Next, the arrow goes up. Up is negative, 50. Next, you see the arrow comes down. Down is positive, 36, plus 36. Minus 150 plus 120 is equal to minus 30 kilonewton. Next, we will calculate shear force at B. Shear force at B. From here to here we will calculate. This is left side. You see the arrow comes down. Down left side is negative, minus 30. Next, you see the arrow comes down. Down is negative, minus 30, equal to minus 60 kilonewton. This is left side. Now we will calculate right side. Shear force at B right. You see this is the shear force at B. B left, B right we will calculate. From here to here, this is left side only. You see the arrow comes down. Down left side is negative, minus 30. Next, you see the arrow comes down. Down is negative, minus 30. Next, you see the arrow goes up. Up left side is positive, plus 100, equal to plus 40 kilonewton. You see up to here only we will calculate. Up to here 3 forces only is there. So 40 is the answer. Next, shear force at C. C left we will calculate now. Shear force at C, from here to here we will calculate. This is left side. First we will calculate left side. Left side means up to here. Right side means up to here. From here to here is left side. From here to here is right side. But we will take only left side rule. No need to take right side. You see the arrow comes down. Down left side is negative, minus 30. Next arrow also comes down is negative, minus 30. Next arrow goes up. Up is positive, plus 100. Next arrow comes down. Down is negative, minus 54. Next arrow goes up. But we will take only left side. Up to here only we will calculate. So no need to take this one. So what is the answer? Equal to minus 14 kilonewton. Next, shear force at C right side. So right side is up to here we will take. First arrow comes down. Down left side is negative, minus 30. Next arrow also comes down, negative, minus 30. Next arrow goes up, positive, plus 100. Next arrow comes down. Down is negative, minus 54. Next arrow goes up. Up is positive, plus 50, equal to 36 kilonewton. Next, shear force at D is equal to 0. Shear force at B, left is minus 60 kilonewton, right is plus 40 kilonewton. Shear force at C, left is minus 14 kilonewton, right is 36 kilonewton. Shear force at D is equal to 0. Now we will draw shear force drawing. Shear force at A is minus 30. So minus 30 comes here. Next, shear force at B minus 60. So minus 60 we will take it here. This is BL. BR is 40. 40 plus 40 is here. Shear force at C left is minus 14. So minus 14 is here. Next, shear force at C right side is 36. 36 comes here. 36. This is CLCR. Next, D is 0. This is point load. Draw the straight line. Next, this is UDL. So UDL joins inclined line. Next, it goes up. The line goes up. After that, this is UDL. So it comes inclined line. Next, it goes up 36. After that, this is also UDL, right? So it comes inclined line. This is positive. This is also positive. This is negative. This is negative. This is shear force drawing. Now we will calculate bending moment calculation. Now we will see two rules. First rule is positive bending moment. It goes clockwise is positive. It goes anti-clockwise is positive. This is left side. This is right side. Positive bending moment. This is first rule. Second one, negative bending moment. It goes anti-clockwise is negative. It goes clockwise is negative. This is left side. This is right side. Negative bending moment. Second rule. Bending moment at A. What is bending moment? Algebraic sum of the moment of the forces to the left or right of the section taken about the section. We will calculate left side bending moment and right side bending moment. Both answers should be same. Now we will calculate only right side. Bending moment at A. This is the force. No distance is there. So bending moment at A is equal to 0. If you have applied moment in the point A, that force should be 0. The distance of the force A is 0 and the moment also 0. If you have applied moment at the point D, that force should be 0. You see here no distance is there. Distance of point D is 0, moment also 0. So we will take bending moment at D is equal to 0. Next we will calculate bending moment at B. You see here bending moment at B. You see this forces comes this way. This is left side. So this way is, you see left side is minus anti-clockwise. So minus 30 into perpendicular distance is 2.5. You see this force from here to here. You see it goes this way. This is anti-clockwise. Anti-clockwise is minus 30 into what is perpendicular distance is 1.25. Minus 30 into 2.5 is minus 75. Minus 30 into 1.25 is minus 37.5 equal to 112.5 kilonewton meter. This is minus. Next, bending moment at C. C is here. From here to here we will calculate. You see the arrow comes down from here to here. You see left side is minus 30 into from here to C. 2.5 plus 4.5 is 7. Next, you see this 4, the arrow comes down from here to here is Anti-clockwise, you see anti-clockwise is negative 30 into perpendicular distances from here to here. This is 4.5. This portion is 1.25. It comes 5.75. Next, take this arrow from here to here. It goes clockwise. Clockwise is positive. Plus 100 into perpendicular distance is from here to here 4.5. 4.5. Next, you take this force from here to here is anti-clockwise. Anti-clockwise is negative minus 54 into perpendicular distance is from here to here 2.25. Minus 30 into 7 is minus 210. Minus 30 into 5.75 is minus 172.5. Plus 100 into 4.5 is 450. Next, minus 54 into 2.25 is minus 121.5 equal to minus 54 kilonewton meter. Now we will draw bending moment drawing. Bending moment at A is equal to 0. So this portion is 0. Bending moment at D is equal to 0. Next, bending moment at B. B is minus 112.5. So 112.5 we will take it as here. Next, C is minus 54. So minus 54 we will take it here. So 54 here is 112.5. Now we will draw the parabolic curve. This is UDL. So it comes parabolic curve. Now we will draw the parabolic curve. Next, this is also parabolic curve. This is also parabolic curve. This is D, A, B, C. This is negative bending moment. So bending moment drawing. You see here this distance we don't know. So how you will calculate this distance? This portion to this portion. We will take it as this is X. I will draw here. You see here this value is 40. You see this value is 14. This one we will take it as X. How you will calculate this distance? You see this whole distance is 4.5. This is X. So we will take it as 4.5 minus X. This value is 4.5 minus X. We will do this calculation with proportionality method. X divided by 40 equal to 4.5 minus X divided by 14. You will take X divided by 40, 4.5 minus X divided by 14. Next, cross this and this. 14 X is equal to 40, open the bracket, 4.5 minus X. 14x is equal to, multiply inside the bracket, 40 into 4.5 is 180 minus 40x. Next, 14x plus 40x is equal to 180. 54x is equal to 180. X is equal to 3.3 meter. So this X value is 3.3 meter. Now we will calculate bending moment value. So I will draw here. 30 kilonewton. This length is 2.5. From here to here, 2.5 plus 3.3 is 5.8 meter. Here is UDL load. UDL is 12 kilonewton per meter. From here to here we will calculate. This is left side. Minus 30 into 5.8. Next you see this force. Force acts upwards. Upwards from here to here, this side. Plus 100 into 3.3 from here to here. Minus 12 into 5.8 into 5.8 divided by 2. We will take UDL. UDL is 12 into this distance is 5.8 into B by 2. B by 2 is 5.8 divided by 2. Next, minus 13 to 5.8 is 174 plus 330 minus 203.9 equal to, here is minus 45.83 kilonewton meter. Here is 112.5, here is 54, here is 45.83. This one we will take it as X. This is bending moment calculation. In this bending moment calculation, use only UDL method. Don't use point load method. If you use point load method in this calculation, answer won't come. You can take UDL method drawing to find the bending moment. Thanks for watching this video.